Well, welcome back to those of you who have been following this series, and for those of you who are new to it, welcome. The past few issues of this, I've been trying to lay out kind of background material to kind of bring you into what we've been doing this past summer on Beaubears Island. When we're looking at a climate study, and how climate change affects the plants and animals. What we're looking at is a lot of little stuff. The forest over there is going to look the same probably 50 years from now, unless there's really major change. But at the same time, what we're seeing is that what we call the microforest, things that go unnoticed. And I want to start that today maybe a little bit technical, but you can always repeat these things and listen on. And to begin, I want you to think about a park, wherever you live. Think about a park in your town or even a national park. It could be a beautiful experience. I've been to many. Very neat, very orderly. I'm thinking, the gardens of Versailles or a Japanese garden or something like that. But it's not natural. It's an artificial construct to look beautiful. A forest, on the other hand, like Beaubears Island, can be very disorderly, cluttered, even messy, but it's natural, the way it should be, and that's important. One of the things we looked at, which I quite honestly, a couple of years ago, I would have said I never even noticed it, or I looked the other way. Deadwood. It's a typical feature and a key factor in biodiversity in the species abundance of natural forests. It's generally defined as above and below ground debris, stems, branches, twigs, roots, stumps, but not leaves. Leaves are considered to be litter, which not really fair, but anyway. Functionally, it represents an important component in the forest carbon pool. Where is the carbon? And this floored me. It makes up 20 to 30% of the entire total timber biomass. That means if you're looking at the forest on the island, somewhere between 70 and 80%, yeah, it's standing, it looks like a forest. But 20 to 30% of that total biomass is already on the ground or near the ground. Now, why deadwood? Well, there are many species out there that look at deadwood as their home or their meal. And the number increases as the tree dies and then decomposes. Again, certain species of both animal and plant use deadwood as a permanent habitat, and any kind of losses in deadwood lead to severe losses in these species. You're talking fungi, lichens, mosses, insects, rodents, even birds. We'll get to that too. Now, some of the old pines on the island, if you have a 300-year-old pine tree, you have a diameter of about 21 to 40 centimeters, about a meter or just over a yard. So you're looking at a tree that wide and how big around. Standing dead pines or snags that are a tree that came down and then got caught on something else, they provide nesting areas for birds that will, like a pileated woodpecker, that'll drill into that dead wood and then make the cavity and use it as a nest. And what was fascinating there was that 20 to 35% of all bird fauna, think of all the birds, 20 to 35% of them will use these kind of trees to nest in. They're very important. And again, when you look at the northern boreal forest, you drive around here, you see it all the time. There'll be dead trees. They're dry, they're hard, there's no bark on them. That's what you see. And the further north you go, you see even more of that, especially when the area becomes kind of wet. And even the spruce will be the same thing. You get your black and red spruce, white spruce. They all get the same way. These old-growth pine forests, they host a lot of specific species that look to these kind of dead woods to live. It's a food source. The deadwood depends on a variety of chemical and physical properties. The nutrients, the moisture, the pH levels of, acidic or alkaline, as well as how much bark cover is on it, the density of the wood itself, the cellulose, lignin, how's that figuring in. And during the late stages of decomposition, deadwood becomes more homogeneous as it kind of rots down. And the interesting thing is the more it rots down, the more you get the proportion of ground-dwelling species increases there. It's like come to the feast. And as such, you can actually see distinct communities that can be determined to the developing stages in an evolving forest. These all go hand in hand, from a young sapling to a dead tree that's been down for decades. All of this comes into being with the animals that will come to these places for food, shelter, and clothing, in a sense. Now, until recently, though, deadwood was perceived as a very negative element in forests. The ecosystems, oh, it's not healthy, look at that. Now it's recognized as a very important component in the functioning of forest ecosystems. Coarse debris, as I said before, depending on the size, can take upwards to 1,000 years to completely decay from a tree that has died and fallen to complete decay into soil. Now that depends on the species, the climate, the position relative to the ground. Is it a snag? Is it lying down with still branches? Have the branches gone and it hits the ground? All of those things come into play. And decomposition simply is the process by which organic material is broken down by physical and chemical reactions and microorganisms, and yet temperature and moisture appear to really be the driving forces in it. Now, what that means is that, like right now, it's cold, there's some snow out there, but not much is happening. But as soon as that vernal sun comes back and warms up everything, things begin to melt, there's moisture out there, stuff starts to just work. Got the hot summer and then into the coolness of the autumn. That's the time. And that's when everything gets to work. Now the first stage is recently dead wood. It still has intact bark, twigs, branches, a roundish shape, a smooth surface, the texture is still intact, and its position is elevated to support different points. Like I said, you'll have tree falls and there'll be still branches, and so it's holding up, there's airflow underneath, over. That's the first stage. Next, the twigs, the branches, and the bark begin to fall off, break down. The wood becomes much softer. It becomes fragmented. And its shape simply becomes flatter. And as it hits the ground, of course, it has nowhere to go. So everything that stays there decaying, and everything else kind of goes down with it. Last of all, all the extensions beyond the trunk are gone. I mean, you have the bottom half, everything is kind of rotted away at that point. The wood is very soft, highly fragmented, and it's in total contact with the soil to which it would become. Around 25% of all forest species will be somewhat dependent on that decaying wood as a source of food, shelter, and breeding sites. So what would happen if that wasn't there? Well, those are the ramifications. Deadwood is an environment for natural regeneration. And what they're called is nurse logs. And this was wonderful to be watching this last summer. The trees will let their seeds go and they float in the wind, and all of a sudden here's this log and it's kind of wet and there's still bark on it, and seed drops in a little crevice. It's found shelter. Now, given how long that will take, at least maybe to the next year, you get a little seedling like that, and it's on its way. It finds the substrate to grow in, the moisture, the temperature conditions. It takes root and begins to grow. By the time that tree goes down into soil, that little seedling is now a little tree. And that's how it does that. And there's moss and other little seedlings, amazing stuff. A little bit of mushrooms here and there, and they're all interacting on this dead tree. And the more the tree is decayed, the better for life. Out of death comes life. Now, deadwood also interacts with that flow of energy that I talked about in the last series here. And it's the nutrients that it gives off into the ecosystem. It acts basically as a natural fertilizer, all of that, and that's what that leaf litter does. That breaks down fairly quickly. And what the earth is doing is taking the stuff that grows on it, introducing it back into the soil so that the next go round, it's like the chicken and the egg. You know, if you had the egg, you'd get a chick. And this kind of fertilizer that goes into the ground can last for centuries. So the whole idea is leave it alone. And deadwood in the forest ecosystem increases productivity. So the more messy it looks, the more healthy it is. Got to think that over. It's a key element in biodiversity, a real key element, especially in the conifer-dominated forests of the Acadian forest, which we're in, that you find in the Atlantic and boreal regions. And the amount of deadwood is now considered an indicator of biodiversity. The more, the better. The rates of decay depend on, again, the chemical composition of the wood, and that's specific to each species. And here's a snag. Pines and spruce and other conifers have resins. You know, you cut it, ooh, what's that smell? That's the resin. Now, they can also be decay resistant. But it's the overall diameter of the tree, say the pine or the spruce, that will determine its composition, along whether, you know, it's standing or lying down, and the temperature and the moisture, but all of that will interact to bring about the future. That's the thing. So the next time you're in the woods or on the island here, appreciate all of that chaos that you see, because that is nature creating the future. See you next time. Take care.